Hi everyone, welcome to the Tableau Consultant Certification Preparation Question Series Part 6. Do check out the first 5 video for more questions. Going to the next question. A Tableau consultant is working with a large dataset in a Tableau prep where the client want to analyze monthly sales performance but also occasionally needs to examine weekly trend. What is the best strategy to prepare the data for these varying level of aggregation? So here option B is correct. In a Tableau prep, create a calculated fields to allow for dynamic aggregation between monthly and weekly levels. Using calculated fields in a Tableau prep to facilitate dynamic aggregation offers the flexibility to switch between monthly and weekly analysis without the need of separate data sources or external pre-processing. So that's why option B is correct. Aggregate the data to the monthly level in a Tableau prep and create a separate connection for weekly analysis. Creating a separate connection for each aggregation level can be inefficient and lead to increased complexity in the data management. So this option is not correct. Import the data without aggregation in a Tableau prep and manage all aggregation in a Tableau desktop. Handling all aggregation in a Tableau desktop may not leverage the full pre-processing capabilities of Tableau prep. So it will impact the performance and efficiency. So that's why option C is not correct. Pre-process the data outside of the Tableau to create two data sets, one aggregated monthly and other is weekly. Again, pre-processing data outside the Tableau into two separate data set limit flexibility and increase the complexity to maintain the data. That's why option B is correct. Moving to the next question. A consultant is reviewing client's data structure to identify opportunities for performance enhancement in a Tableau. Which areas should be prioritized for review? So here option D is correct. The use of indexing and partitioning in the client's database system. So this is best performance enhancement in a Tableau, that we should prioritize indexing and partitioning in the client database system. Actually, proper indexing and partitioning can improve query performance and leading to faster data retrieval, and this is very efficient dashboard operation in a Tableau. That's why option D is correct. The aesthetic layout of the client's current data dashboard. So this again is more related to visual aesthetic look of the dashboard. It's not related to performance. The number of users accessing the database concurrently. So the concurrent user access can impact performance. It is more of an infrastructure consideration than a direct performance enhancement in the context of a data optimization. So yes, it will impact on the performance, but not related to the database retrieving or data retrieving. And the color scheme used in a client existing data visualization. Again, this is a matter of user experience, do not directly affect the database performance. Moving to the next question. You are using a fixed level of details expression in a Tableau workbook to calculate total sales per region. However, when filters are applied to the dashboard, the calculated total do not change as expected. What is the likely cause of this issue? So here option D is correct. The filter needs to be converted to context filter to affect the fixed level of details calculation. So actually, fixed LOD calculation compute a value based on the dimensions specified in the expression and are unaffected by standard filter. So to have a filters impact the LOD calculation, they must be in a context filter. So the nature of fixed LOD expression is they compute just after the context filter. That's why option D is correct. The fixed LOD expression is not considering the dimension used in the filters. And actually the LOD expression is solely depend on the dimension used in the LOD. So that's why it's not considering the filter values, and it is irrespective of the dimension or filters are used in the workbook. So it's not included, those are not included in the calculation. That's why option A is not correct. The workbook lacks of sufficient computational resources to update the LOD calculation with the filters. Computational resource affect performance speeds, not filter logic interaction. So option C is not correct. And there is a syntax error in the LOD expression. Syntax error would like to result an error message, not in a performance issue. So option B is not correct here. Moving to the next question. A Tableau consultant is designing a dashboard in a Tableau desktop for a retail company that wants to analyze sales data both at a daily level and aggregated monthly level. The data is extensive going back several years. What is the best approach to handle this data for optimal performance and flexibility? So here option A is correct. Set up the data source in a Tableau desktop to default to monthly aggregation with the option to drill down to daily data. This will provide both performance benefit and flexibility for deeper analysis. So option A is correct. Use Tableau Prep to create separate data flows for daily and monthly aggregated. So creating separate flows is a complex and unnecessary. So option B is not correct. Implement custom SQL in a Tableau to fetch data at desired aggregation level dynamically. Custom SQL adds complexity and it will lead to performance issue, and it will reduce the performance versus built-in aggregation capability. Aggregate the data to the monthly level in the database before importing in the Tableau. So again, if you aggregate the data only to the monthly level, uh, we are not using the drill down functionality, or we are not able to use the drill down to the daily data. So option D is not correct here. Moving to the next question. While analyzing a Tableau workbook, you notice a dashboard is taking a long time to load. You find that complex calculated field is used extensively across multiple views. Which approach best optimize the performance? Here option B is correct. Replace the complex calculated field with a simpler equivalent if possible. So if you replace the calculated field with the simpler equivalent, or if possible, you can just trim down the complex calculated field into multiple calculated field, then it will give better result. That's the answer here. Increase the RAM on a Tableau server. This will not address the issue because the issue is in calculation logic. Use context filter on all views. Context filter will not solve the issue, but issue is because of the heavy calculation overhead, and it will add more processing. So option C is not correct. Convert the workbook to use extract instead of live connection. So extract improve performance but in general, but will still execute the same heavy calculation in a live connection also, so it will not impact. So here option B is correct. Moving to the next question. In assessing a company's data structure for performance enhancement with Tableau, what factor is critical to examine? So here option C is correct. The consistency and the optimization of data types and format used in the database, because consistent and optimized data format improve query execution and processing efficiency in Tableau. That's why option C is correct. The brand of hardware running the database, it will not have an impact on a Tableau structuring, so this is not a correct option. CEO reporting preferences, again it does not affect on a technical performance. And data central geographical location, data central location affects the latency but does not internal data and structural optimization. So option D is not correct. Moving to the next question. You are optimizing performance for a Tableau server used by multiple departments. Caching is currently default. Which change would most likely improve performance for all users? So here option A is correct. Set caching to the balanced option, so which adjusts dynamically based on the server load. So balanced option is more beneficial. That's why option A is correct. Keep cache permanently preloaded. So if we keep cache permanently preloaded, it is a resource heavy. That's why it is not feasible solution. Force only live connection. So live connection only ignores the caching benefits and lower the performance, as in the live connection we are not able to use caching feature. Enable caching only during peak hours. So caching only at certain time won't support varied usage timing across department. So if one department is using another time of refresh, or another department using another time of refresh, so this will not solve that problem. Moving to the next question. You are configuring caching on a Tableau server handling real-time data reports. Which setting is most suitable? So option D is correct. Use refresh more often mode. This caching mode, refresh more often, to ensure data freshness. It will load the data oftenly, or cache the data more oftenly, so you can have latest data in your data source. Enable caching for all views and refresh on every load. So this will again give load on a server, so this is not a feasible solution. Completely disable caching. So if you disable the caching, it will increase the load times and resource demand, and you are not using caching feature, so it's not beneficial. Use balanced caching mode. Balance mode may not refresh enough, so it will not refresh whenever required, so this is not a feasible solution here. So refresh more often, it will give the fresh data. So option D is correct. You discover that the Tableau extract is not updating as scheduled, and you suspect the source database is the issue. What should you do first? So here you need to check for issues or change in the source database, because this is the first things to do. If source database is having an issue, then you need to fix that first to get the data. So that's why option B is correct. Increase the Tableau server computational resource. If there is an issue in a database, it will not help with increasing a Tableau computational services also. Change refresh schedule timing. This will not help if there is an issue in a database. Changing the refresh schedule timing will not help in this picture. Tell users to refresh manually. Again, this will be the manual process, and if we refresh the manually, again there is the issue in a database, it will not get the fresh data. So option B is correct. Moving to the last question of this video. You are creating a report analyzing customer purchasing behavior. You need to average purchase value per customer, but only for customers with more than 5 purchases. Which method is correct? So here option C is correct. Nested fixed LOD to filter customer, then compute average. So this will first identify customer with more than 5 purchases and then compute the average. So option C is correct in this criteria. Fixed LOD, total sales divided by total purchase count. Again, this is simple division, and it's not giving a correct average. That's why option A is not correct. Count distinct plus window average, it will it has a segmentation, lack of segmentation logic, so option B is not correct. And basic average then filter later. So if you average all the customer first, then filter will give incorrect values, so option D is again incorrect. Option C is correct. Thank you guys, subscribe for more.